Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Chaconopia Playground by Mad Tias. We've done a couple of these previously, so these are basically just continuations of his series. Let's get to the rules. We have chaos construction, where the grid has to be divided into 9 regions of orthogonally connected cells. And each row, column, and region has to contain the digits 1 through 9 once each. So to be an orthogonally connected region, you have to have all the cells, all the cells in the region. You can go to any other cell in the region just by going through edges, all while staying within the region. So to go from this cell to this cell, you can go from edge to edge and stay within the region. This is not a valid region because to get from this cell to any other cell in the region, you have to either go through a corner or you have to go through an edge, but you have to go outside the region. You could also not have something like this because even though that you can connect to each other from just going through edges, to connect to the other cells in the region, you have to either go through a corner or go through an edge and get outside of the region, which is not allowed. So that is chaos construction rules. We have roles, where cells take on roles if certain conditions are met. These roles increase the value of those cells. Only if none of the conditions, which are described below, is met, the value of a cell is its digit. If more than one condition is met, the cell always takes the role with the highest value. So another way of saying it is the value of a cell is going to be its digit unless it fulfills any role. And whichever role it fulfills has the highest value, it takes that value then. And here are the role mechanics and values. X is equal to the digit in the cell. If a cell is a farmer, it has value of 2 times its digit. And to become a farmer, a cell needs at least X digits, including itself, of its own region in the 3x3 area centered on the cell. So, basically, in the 3x3 area surrounding a cell, you need however many, whatever the digit is in your cell, you have to have at least that amount of cells in the same region as it to satisfy the farmer role. To satisfy the merchant role, it has a value of 3 times the digit. To become a merchant, there has to be at least one foreign region that occupies at least X orthogonally and or diagonally touching cells of the considered cell. I like to just say, I'm not sure why, but it should be like, I feel like that all the rules should be basically have the same explanation because it's basically the same. So whatever cell here, in the 3x, to work as a farmer, you have to have whatever the digit is of in the same region in the 3x3 box centered around the cell. For a merchant, you have to have one single foreign region have the digit amount of cells in the box. So say this was a 5. This would be satisfying if this was a foreign region, which has 5 cells in the 3x3 box that is surrounding the cell. And then finally, we have diplomat, where you have a value of 4 times a digit in the cell. And to become a diplomat, a cell has to be orthogonally and or diagonally touched by at least X different other regions. Or again, in this 3x3 area surrounding the cell, you have to have X number of other regions in that 3x3 space centered around the cell. And those are all the roles. And then finally, we have clues, where the value of the cell n steps away in the direction of an arrow is given in the corresponding circle. The value of the cell n steps away. N is the digit in the cell from which the arrow extends. Okay, so as an example, they have row 1, column 3 would be a 3. So if row 1, column 3 is a 3, then the value of row 4, column 6 would be 12. Because this is saying 3 cells going in the arrow's direction has to have a value of 12. That's what it's saying. So that's an example of how the clues work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Let's look at the easiest ones. This can be either 1 or 2. We're not sure which. So this is 1 or 2 in that cell. This goes 1 through 4. So this is 1 through 4. But if we try to have a 21 here, so 21 has to be a farmer, because it's essentially only 3 times 7. Now the thing is, this cell doesn't have 7 cells surrounding it. So this cannot be 4. It can be 1, 2, or 3 here. This has to be 1 or 2, because it points that direction. So this is 1 or 2, which means this has to be a 3, because we have a 1, 2, 1, 2 pair in column 5. So this is 3, which means this has to have a 21 in value, and this must be 21 in value. So this must exit out here. We have to have this cell, so this cell must have value of 7. So this must be 7, and this must be 7. And this is a separate region than the surroundings, and this is a separate region than the surroundings. And this has to go out somewhere. This has to go out somewhere, so it goes either that way or it goes that way. So this is blue, and this is light, because you have to have 7 cells surrounding this cell, which must be of one foreign region. Okay, 1, 2, this has a value of 18. This is 1 through 4. This is saying 7 has a value of 2. 1, 2, 3, 4, 5, 6, 7. We know, okay, so 1 and 2 can always has to have at least a farmer role. So 2 can never actually be the value of a cell unless it's 1 as a farmer. So that means this must be 1 as a farmer, because there's no other way. You can't have 2 here without it being a farmer also, which would mean its value is 4. So this 1 essentially has to be surrounded, cannot have a merchant, cannot be a diplomat, which means there are no other regions that are in the 3x3 box surrounding it. So this must be the same region. This is either a 1, a 2, or a 4 in value, because a 4 can be just a normal, it does not have to be a farmer. 1 and 2 always are farmers, because 1, obviously, it satisfies the farmer of just having 1 cell around it in the same region. But 2 is also because every region is orthogonally connected. and therefore it must connect outside to somewhere else, right? So this is 1. This has a value of 4, and it could be 1, 2, or 4. Okay. This cannot be 3. This has to be 1, 2, or 4 in direction going this way. This has 1, 2, 3, 4, 5, 6. It could be up to 6. You don't know which. 18. So 18 either is a farmer of 9 or a merchant with 6. That's for all the 18s. Okay. Farmer of 9. This is can go 1, 2, 3, 4, 5, 6, 7, but it can't be 7. So it's 1 through 6 here. This is all the same region. Because this is a farmer of 2. 14. So this goes this way. 1, 2, 3, 4, 5, 6 is possibilities. Cannot be 1. It cannot be 5 because this has to have it has to be a farmer with value of, it has to be with a digit of 7, right? 2 times 7 is 14, and that's the only factorization that works for that. So it cannot be 5 here. Can it be 6? I don't think it could be 6 either. If it's 6, 1, 2, 3, 4, 5, 6, it would have to have 7 cells in the same region in the 3x3 spot around it, and it can't be that. At least 7, shall I say. Remaining digits in column 5. Let's do 4 through 9. This can't be 7. 4 through 9. 4 through 9. 4 through 9. Okay. Has a value of 10. So that means it has to have a farmer rule. So this has to have a value of 10. It's a farmer rule because it has to be 2 times 5. This cell, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's possible to be 5 that way then. Oh, but this can't be 5 because it would be 1, 2, 3, 4, 5 as a 7. So this cannot be 2. This has to be 1. So this has a value, it's either 2 times 9 or 3 times 6 to multiply to 18. This has to be 5. So this must be a value of 5, which means this can't be 5. Can it be blue in value? I don't think so, right? That'd be 1, 2, 3, 4, 5, 6, 7, 8. Oh, it could be. Could be blue in value. 9. Can it be a farmer with 9? No. If it's farmer with 9, that would mean that this has to be, all of these are the same region. But the problem with that is blue already has different cells here, so it cannot be. So this must be a merchant of 6. This could be blue. In fact, it probably is blue because so this cannot be 2 away. It cannot be 1, 2, 3, 4 away because it has to be 7 times 2. So this is 3 away, and this is 7 times 2. So it's a farmer, which means 7 of the cells surrounding it, at least, have to be the same region. Okay. Um. Hmm. Here we're looking. Okay, so this cannot be 7. If this were 5, the problem is that the cell that it points to could not be 5. It could not have a digit of 5. So this cannot be 5. So it's 1. It could be 1, 2. It cannot be 2 because we have a 5 in that column. It could be 1, 3. Cannot be 4. It could be 6. To have a value of 2 times 5. So this is done. This is done. Okay. Can this be pink, essentially? I think the answer to that is no. I guess this could be pink, but then the problem is... So say this was pink, essentially. That's not too helpful. This has to have a value of 12. So this is pointing at 3 times 4, or 4 times 3, or 2 times 6. So this cannot be 2 away, because that's not, cannot be... Oh, this is 1, which forces this to be 2. So this cell cannot have 9 cells as a farmer, because then it would all be the same region, and we know this is a separate region. So this is also 6. 2 away, this has to be 5. So this must be 2 times 5 as a farmer. That means it cannot, this is definitely a different region. Okay, so yeah, let's mark the region borders. We know these are definitely separate regions. This is definitely a separate region. So since this is a separate region, this has to satisfy the farmer rule to be have 10 times, which is a value of 2 times 5. So these all must be light, which means this has to go that way. We're going to mark that as green. So all the light is done. We have 9 cells in that region. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. This 5 away is 12. 1, 2, 3, 4, 5. So it can be 3 or 6 here. This 15 must have a merchant value of, must be a merchant, because it can only be 3 times 5. Well, 5 can't be 1 here because of the 5 in the column. Could be 2, could be 3, cannot be 4, cannot be 5, obviously, because then this wouldn't, you wouldn't have a 5 available in the row. Could be 6, and cannot be 7. So this is 2, 3, or 6. This is either, again, 3 times 4, or it's 2 times 6. Cannot be 4 away because that's 7. So 3 or 6 has to be the 5 in this row. We have to have a 5 in, that's 2 away, 3 away, 4, 5, or 6 away. Okay. Hmm. 12 away. Okay, so this is Okay, so cannot be 3 away. Well, couldn't anyways. Can't be 1 away, can't be 3 away. Could be 2, could be 4, because this is 3. And this has to have a 3 or 4 in value. Or 6. Could be 2, 4, 5, 6, 7, 8. So any of those work. This could be 1 through 8. No 5, though. This can't be 5. So this has to have one region, which is one foreign region that occupies at least 6 cells. So this must be all green here. So this one's done. This one's done. That's done. That's done. Wait, can this ever be 4? If you're a merchant, that has to be 6 in value, but it's 4 away. That means a foreign region occupies at least X cells. And there's only 6 cells in the 3x3 area surrounding this cell. So that's not possible. And to be a farmer, you have to have 9, which again, this only has 6. So that's not possible. So this cannot be 4 here. This is 1 or 2. Can this be 4? It's either a diplomat of 4, or it's a farmer times 8. Or it's a farmer of 8 times 2. And this 4-way cannot have 8 cells of the same region in the 3x3 region around it. And you can't, and since this is all the same region, it cannot have 4 other regions that are touching it. So this cannot be 4 either. So this is 1 or 2 also. 4 through 9, 4 through 9, 4 through 9, 4 through 9. And this can't be 7, no 7, no 7. No, this could be... This could actually be 7. No 5 or 6. So 7 has to be one of these 3. Okay. Okay, so we have this arrow. That's done. This is done. This is done. Oh, 1, 2, 3, 4, 5. That's not quite done. This is 6 here. So this cannot be 4 away, because 4 away would be 3 times some value to try to multiply to 8. Cannot be 5 because of the 7. These are essentially done. Okay. One of these has to be an 8 or 4. Oh, that's quite broad. I guess this could be 5. Yeah, this has to have a foreign region have 5 cells in the 3x3 box that surrounds it. It's possible. So if this is 2, this has to be a 9. If this is 1, this could be 6 or 9. If it's 9, these... Okay, so if this is 9, these are all the same region. If this is 9, these are all the same region. So far, these sets are same regions. If this is a 6... that doesn't really tell us too much. Okay, what are the remaining cells in the light region? We have... 7 cannot be here or here. And can't be these two. Can't be here because of the 7 in the column. So 7 in the light region has to be one of these two, which means this cannot be 7. So in row 5, the 7 has to be one of these two. Okay. 4 or 8 is here. 9 or 6 is here. Okay, this 6 is a merchant, so it has to have a foreign region that occupies 6 cells. The blue region cannot be that foreign region, because this has 1, 2, 3, 4, 5, 6. It only has 3 more spaces here. So 1, 2, 3, 4 is possible, but that's it. 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so that's not gonna happen. So blue cannot be the region that has 6 cells. Say this is another region then. Say it's like a yellow. Then this region has to have 6 cells. Yeah, that's not gonna work either. So say it's a yellow region with another region being the 6. You can't, I mean, the yellow region has to go out. I guess this is possible? No, but then the blue region's going to be surround. Yeah. One of these is blue, the other one is the other color, right? So this is, we're going to mark that as orange. The problem with this being some other region is this blue has to connect to one of these. Say it's some other region that's 6. Well, then the yellow is not part of an orthogonal connected region. So say it's this orange or whatever. Then even if this is the case, 2, 3, like this can go to here, but the problem is the yellow has to get out as a region, but then this can't be 6 here. So we pretty much certain then this has to be blue. So this is blue. If it's blue here, it could be 1, 2, 3, 4, 5, 6. That is working. Otherwise, it could be 1, 2, 3, 4, 5, 6. Okay, so what's the region here? So this is blue. This is blue or orange. Blue or orange. This is not blue. This is orange. And this is blue or orange. So it could be some sort of yellow. Can it ever be pink is the question, right? So we know this is all the same region. Right? Because actually it has to be 5 here. And it could be 6 here or 6 here. But this has to be the same region. Can it be pink? The answer to that, I think, is no. Because you have 1, 2, 3 at least outside. Right. So this cannot be pink then. And since this can't be pink, because you have to have surrounding regions here be at least 6. if we try to make this the pink region, the problem is that this would then not have 7 cells of the same region around it, right? We'd have already 3 outside, and therefore this would only be 6 at most. So this has to be all pink then, because this must be a separate region. So these are different regions because this green has a 7 and this pink must be 7. So these are all green, pink, and red. We have 7 here. We have 1, 2, 3, 4, 5, 6 here. So the pink can only contribute 2 to here. The green can contribute 3. That means the rest have to be at least red, 2 reds, and maybe more. And 1 red would then be here. At most. So pink could go all the way here. 2 cells. Green could go 3 cells. So technically could go all the way here. Red can go 3 cells this way. So this has to be green here then. Because there's no other place, no other region can reach there, right? This is 2 cells here. This is 3 cells here. And this is 3 cells this way. Okay. We have this is at most 2 plus 3. So we're guaranteed one of these is green. So we have green 1, 2, 3, 4, 5, 6, 7. One of these is green at least. 8. So then these could be green. But we don't know. Could be also medium. Pink can go 2 out this way. 2 out that way. 2 out this way. This is a separate region. These could be yellow. This has to be a boundary. We have 1, 2, 3, 4, 5, 6, 7, 8 blues. So blue can only go 1 more out. So these could be blue and this could be blue. And those are the totality of the blues. Yellow could go here. If this were essentially yellow, quote unquote, it would be the same as orange. So this actually has to be yellow, and it can go pink twice here. Can it? Yes. No. It cannot go 2. Because, and these could be red though. So all of these could be, this can't be red. Because then this would not have 6 cells in the same region there. Red can go, can you go 3 there? No. I don't think this could be red. Because if this were red, because this pink can only occupy 2 cells of this 6 cell region. This green can only occupy 2 cells. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there has to be 2 reds here, which means this red can only go once. So this must be yellow, guaranteed. We have 1, 2, 3, 4, 5, 6. So 5, 6. We have a guaranteed 7 somewhere here. Seven, 8. Okay, is any one of these a farmer with 8? This could be. Otherwise, you have to have a merchant have... diplomat has to touch 4 other regions. There's no way any of these cells can be a diplomat. of 4 other regions, right? You only have green, red, and yellow available here to be touching it. So this has to be a merchant, and this can't be 8 because we already have 2 cells here. So this must be 8 here, which makes this a 1. That means this can't be 8. 2, so 2 out of these 3 cells are pink, which means pink cannot be here. Pink cannot be any of these. This could be yellow or some orange or something. So this is done as a region. This cannot go this way. This has to be a farmer of 8. This can't be pink. So we're guaranteed 2 of them are here. So this must be pink. Well, it could go that way. That is possible. Green has at most 2. So this is guaranteed to be red. So we have 7 here. Green can be up to 2. Red has to have at least 1, but we don't know which one. So say this was the same region. We have 1, 2, 3, 4, 5. I guess it's possible. 1, 2, 3, 4, 5, 6, 7, 8, and then 9 as a yellow. Because we're guaranteed one of these is yellow. So one of these is guaranteed to be yellow. Therefore, this can't be yellow here. This could be some sort of orange here. Okay, remaining digits in the pink region are 2, 4, 5, 6, 9. Not 8. This can't be 5 or 6 because of the 5 or 6 in the column. This can't be 6 because of the 6 in the row. Okay. Can this be 5 as a merchant? I think the answer to that is no. This has only 1, this has only 3. This could be 2 at most, so this cannot be 5 as a merchant. Can this be 5 as a merchant? The answer to that is no. Because if this is green, this is 2 at most, this is 4 at most. If this is another region, we have 4 here already that cannot be part of a set of 5 digits of the same foreign region. So then you have only 4 there. So this has to be a 5 then. So this is 1, 2, 3, 4, 5, 6 away. So this is a 6 here, which eliminates 6 here. This must have a foreign region that has to have 5 cells. So this is a farmer with 5 cells. This cannot be that 5. Because we have 1, 2, 3, 4 cells at most on this cell here as a farmer. So this cannot be the 5, which means this must be the 5. So this has to be 6 away. 1, 2, 3, 4, 5, 6. Yep. And it must be a farmer. So it cannot be blue. Because we have, well, yeah, can't be blue. This is 5, the only one that works. It cannot be green because we already have 1, 2, 3, 4, 5, 6, 7 in the greens. Cannot be red because we already have 7 in the reds, which aren't surrounding this. Or 6 in the reds not surrounding this. We have 7 in the greens not surrounding this, so this must be pink. So this has to be pink. It's with pink in one of those 2 areas. This can't be 5. That also eliminates 5 in the rest of the pink region. This can't be 6 because of the 6 in the row. This can't be green anymore. So this is pink or red here. Okay. This can't be 6 anymore because of the 6 in the row. This 5 has to have a foreign region occupy 5 of its neighboring cells in the 3x3 area. 3, so okay. 5, now this is 6, so it has to be a farmer of 6. Okay. It technically still could be a completely separate region here. Yeah, that is possible. This 5 has 5 of the same region around it. So that's done. That's done. This 6 has 6 in the same foreign region. This one is all the same region there. This 8 eliminates 8 here. So this is 4 or 9. This is the same region as this 5, so this cannot be 5. Therefore, where is the 5? In column 5, it has to be here. So that's a 5. Because the blue has already 1, 2, 3, 4, 5, 6, 7, 8 cells. So it can only go one this way. The red has to be at least 2 of these cells here. And the reason why we knew this was red, pink, or green is this was a 6-cell region, so it couldn't be a separate region, right? So one of these is obviously pink. One of these has to be a 2 then, because this can't be 2. Oh, this 1 eliminates 1 here, so this is 2. Therefore, this must be a 9. So this must be the same region. We're going to mark this as gray. This could be some sort of dark region here. It cannot be 6 here, because this is 2 away. So this is 9 as a farmer, because therefore it has to have all the cells in the 3x3 area be the same region. So this is done. These both could be dark. I think this is guaranteed to be dark. If it's green here, what color cell is that? There's just no color it could be, right? Pink is already all done. The medium is all done. With the green going here, we have a guaranteed green here. So that's all done. So yeah, this cannot be green. This has to be dark, which means all of this is dark. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Or it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So dark could be either of these. This could be some sort of orange, I guess. In fact, it actually sort of has to be orange. This could be orange or yellow, essentially. If it's yellow, it goes that way. If it's orange, I think it has to go this way. So this is yellow going that way or orange going that way. I can't read this. That's 8. Obviously can't be 2 away then now. This is 5, so this must be 5 of the same region in a foreign region. So this cannot be dark. It has to be all orange. So this is all orange. This farmer has to have 6. I think it has to be... This is definitely distinctly different than this. Because this is already 5 here, this is 5 here, so they have to be different regions. Can it be yellow? I don't think so. I think this has to be orange. So this is orange. We have 1, 2, 3, 4. Okay. So this is done here. we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this can't be green. This is dark. This is done as a region there. We have 1, 2, 3, 4, 5, 6, 7, and it's either 8, 9 or 8, 9. So this is always green. This can't be red. This cannot have a 6 here then because it's green. This 2 eliminates 2 in the rest of the region. So this has 5 of the same region as a merchant. This is 1 or 4. If it's 1, it would have to be a diplomat. But that doesn't work because it's not touching 4 different other regions. So this must be 4. Wait, that satisfies a farmer. That's not good. What did I do wrong? Yeah, that satisfies farmer, so that's no good. Oh, wait. No, diplomat works. Diplomat works. Diplomat works. This cannot be 4, right? Diplomat works because it has to be touched by one different other region, which it is. So that's 1. Cannot be a farmer because that would... It cannot be 4 because that would be a farmer, then would have a value of 8. So that eliminates 1 from that region. Okay, so that's good. Okay, so again, this is... We know the number, what this is, and but we haven't satisfied it yet. This is satisfied as a farmer of 5, which is 2 times 5, which is 10. This is satisfied as a merchant of 6, because it has 18 in value, and it's surrounded by 6 cells of the same foreign region. This is satisfied as a merchant 5, because you have 5 cells of the same foreign region occupying 5 cells. This is satisfied as a farmer 8. This is satisfied as a farmer 9. This is satisfied as a merchant 7. This is a merchant 7, but we don't have it satisfied yet. Those are done. 6 away. This satisfied as a farmer 5. Either way. This is not quite satisfied as a merchant 6. This is satisfied... Wait, this is 10? I think that's 10. That means it has to be farmer 5. So one of these 2 is a yellow. Interesting. At least one of those 2. Could be both. Obviously could be yellow, yellow, yellow. So 1, 2, 3, 4, 5, 6, 7, 8, and then 9 here. So one of these is definitely red. One of these is definitely yellow. So that's 7 yellows here. If this is not yellow, that means this is blue. So we have 1, 2, 3, 4, 5, 6, 7, 8. This would then be yellow here. This could be orange, orange, orange. One of these would be blue. One of these would be orange. This 6 eliminates 6 in the rest of the orange region. Where is the 6 then in row 5? It has to be here. So that's 6. Okay. So we haven't done that yet. This has to be... Could be 2 away. 4... You could have 3. 2 away. Could be 4 away as a diplomat. That actually works. This is definitely surrounding... 4 other regions are definitely touching this. So 2 works, 4 works, 5. Could work as a 3, right? It's touching 3 other foreign regions. So 2, 4, 5 works. 6 does not because it's 9. This does not work as a merchant or a diplomat. So this could not be 8 away. This value is what, 8? Yeah. So this cannot work 8 away because it can't be 8 anymore here to satisfy that, right? Because this is 12. That would force this to be a 3. And that would have a merchant value. This would have to be 3 times 4, which would mean it's a diplomat, which means it's touching 3 other cells, 3 other regions, which it obviously isn't. So that's the reason why this can't be 8. This can't be 8 anymore because then this can't be 8. And it doesn't satisfy... Oh, it does satisfy farmer. It does satisfy farmer. So that could be 8. 3, 1, 2, 3. 6 away. It could be 2 times diplomat. That's possible. Or 4 times... 2 as a diplomat or 4 as a farmer. Both work. Okay. Okay. Where is 2 in column 9? Can't be dark, can't be orange. So it has to be one of these digits here. This can't be 2 because of the 2 in the row guaranteed. 1s. Where is the 1? So for the light region, it cannot be here or here. So the 1 has to be one of these 3. For the green region, cannot be here or here. So it has to be one of these 5. Okay, we have yellow already done. Blue could be 1. No, this can't be 1. 1 cannot appear in the yellow region. Can't appear in the dark region. Can't appear in these rows because of the 1s in the rows. So this one of these must be a 1. Where's the 1 in column 7? It has to be in the blue region. And it cannot be here. So it has to be one of these 2. In fact, where's the 1 in... Well, I guess... No, this has to be a blue. Actually, this could be orange. Never mind. This could actually be orange. And then in column 9, it's in the orange or blue region. It could be here. It could be here or here. Okay, that's kind of broad. 6s. 6 can't be in the light or the green region anymore. So it has to be red. It cannot be here. So 6 cannot be here. Because that'd be 1, 2, 3, 4, 5, 6 away. Which has 9 multiplied with another integer to try to multiply to 12. Which is impossible. Can't be light. Can't be green. Even if this were red, it can't be there because of a 6 in the row, so this must be 6 here, which eliminates 6 here. Hmm. Where is 6 in row 9? Can't be any of these cells because of 6 is in the column. Can't be here, can't be here, can't be in the blue region because this is blue. So it has to be here. So this is 6 guaranteed, which means this cannot be 6. Where is 6 in row 1? It has to be in the dark region, so it's one of those 3. Where is 6 in row 2, then? It cannot be the light region, cannot be the dark region, so it has to be the medium gray region, so it's one of those 6s. And this can't be 6, this can't be 6 because of 6 in the column. This can't be 6 because of 6 in the column. Where's a 6 in row 2? Can't be any of the light region. This is already filled. This is filled. This can't be 6. This can't be 6. And this can't be 6 because we can't have we need a 6 in the dark region in row 1. So this must be 6 here, which means this cannot be 6 here. Therefore, this is a 6. This does not work as a farmer. I guess it could have been a farmer technically, but okay, so 6 away. 1, 2, 3, 4, 5, 6. So it cannot be 9. It's either 2 or 4 here. 2 as a diplomat, 4 as a farmer. And it satisfies 4 as a farmer. It could satisfy 2 as a diplomat if this is yellow. So now this is done. Essentially. That should be all the 6s. It is 5s. Where... 5 in row 5 has to be one of those 2. Five in row 3 can either be here or here. Cannot be light, can't be in this column, can't be in medium, so it has to be one of those 2. And in row 5, it's one of these 2 also. So therefore, we have a guaranteed green 5 and a guaranteed orange 5. We need a guaranteed blue 5. Where is the 5 in blue? Cannot be here. Can't be here because we're guaranteed a 5 in the orange in one of these 2 cells. So no here, no here. Cannot be here or here. Or here because of 5s in the row and columns. So 5 has to be here for the blue region. 5 cannot be here for red, cannot be here for red. Wait, these cannot point to the same cell. Because this says that cell has a value of 8, and this cell says it has a value, this arrow point says it has a value of 12. So this cannot be 2. It could be 4 away. It could be 5 or 7. Okay. Um... Ugh. Hmm. This can't be 7 because of 7 in the row. So we're guaranteed a 7 in the dark region. Hmm. All the 6s are done. Seven cannot be here. Cannot be here. Cannot be here. So 7 in the, or here. So 7 in the red region is one of these 3. I need to resolve this, I feel. So we're guaranteed 7 yellows here. One of these is another one. So if it goes this way, this is yellow, yellow. And I guess this could be yellow. Wait, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So if it goes yellow, yellow, none of these are yellow. That means this is blue here, if that's the case. Otherwise, this is blue and then this is yellow. This could be orange, orange, and this would satisfy the 6. As a farmer, yeah, they both work. Okay. Let's do remaining digits now. We're far enough along, but the problem is we're running into some issues. Remaining digits in row 7. We have 2, 3, 4, 7, 8, 9. This can't be 2, no 2, no 2. This can't be 7. This can't be 7. This can't be 3 because it's part of blue. All right, we should do that. Well, no, that could be yellow. Never mind. Okay, what happens if this becomes both orange? So say it's orange, then this cannot be yellow, that's blue, which means this to be farmer 5 has to have yellow here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That can't be 7 anymore, so this must be a yellow 7. So I don't think this can ever be yellow. If we try to have yellow here, if we add yellow here, that's 1, 2, 3, 4, 5, 6, 7, guaranteed 8 as a yellow, and it cannot be both of these, so therefore it'd have to be here. But then this would be orange, orange, and it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the problem is this would have to be yellow also. And we would have 10 yellows in this cell, which is not possible. So this cannot be yellow. Since this can't be yellow, this must be the yellow here to satisfy this blue. This must go then this way to satisfy there. This orange has to be 3 oranges here. So this cannot be orange. This is yellow. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9 guaranteed here. So this can't be yellow, that's blue. This can't be yellow, that's orange. So that's satisfied there. Okay, this can't be 2 because of the 2 in the orange region. Hmm. This can't be 3 because of 3 in the blue region. This can't be 1 because of the 1 in the yellow region. Where's the 1 in column 7? It has to be here. So this is 1. Remaining digits then in column 7 are 4, 7, and 8. So this is 4, 8, 4, 7, 8, 4, 7, 8. But we already have a 7 in the dark region, so this can't be 7. We have a 4, 8, 4, 8 pair in column 7, so this has to be a 7 here, which eliminates 7 in the rest of the row. So that leaves this as a 7 in column 5. And this must be 3, 4, 8, and 9. And 3, 4, 8, and 9 here. Okay. We have in the yellow region a 4, 8, 9 triplet, so that leaves just 2 and 3 available in the yellow region. Okay. This is 1. So this cannot be 1 in the orange region. So where is the 1 then in column 9? It has to be here. That makes this a 2 because there's no other place for 2 in the blue region. Where is 2 in column 8? Can't be blue, can't be filled out cells, can't be orange. This is filled. Can't be 2 here because of the 2 in the row, and this is filled, so this must be 2 here. Remaining digits are 3, 4, 8, 9 in the column 8. We have a 4, 8, 9 triplet, which eliminates 4, 8, 9 in the rest of the column. So this can't be 4, 8, it's 3. That leaves these 3 cells in the medium gray region as 1, 4, and 8, which eliminates 1, 4, and 8 in the rest of the column. This can't be 4, 8. This can't be 4, 8. This can't be 4, 8. So this is 7 or 9 here. We have a 7, 9, 7, 9 pair in column 6, which eliminates 7, 9 in the rest of the column. So this is 3. This can't be 3. This 3 eliminates 3 here, so it's 2. The yellow has to have access to a 3, and it cannot have access to a 3 here. So this can't be yellow. This is red, which forces this not to be red, so this is yellow. That's done as a region. This must be a 3. Okay. Remaining digits in row. This can't be 1 because of the 1 in the row. This has to be 3, 4, or 9 in the rest of row 6. Okay. The rest of this orange column 9 cannot be 7 because we already have a 7 in the orange region. So it's 3, 4, 5, no 6, 8, 9. This can't be 3, this can't be 5. We're guaranteed one of these is a 3. So that's fine. Remaining digits in... This can't be 7 in row 1. So that forces this to be a 7 here for the light region because there's no other place for it. That means this can't be 7 here in red and here. That means where's the 7 in the red region? It has to be here. And then the 7 in row 7 has to be here. This is 4 or 5 away. If it's 5 away, it would have to be a merchant of 4. But it cannot be a merchant of 4. Because orange only has 2, dark has 2, and pink only has 1. So this cannot be 5 away. 1, 2, 3, 4, 5. It has to be 4 away as a diplomat of 3. Which it is touching 3 separate regions. So that's fine. This 4 eliminates 4 in the rest of the column and row. This 7 eliminates 7 here, so it's 9, which makes this 7. So this can't be 7 here. This 9 eliminates 9 here, so it's 8. This can't be 8 or 9, so it's 4. This can't be 4, so it's 2. Which means this can't be 2. This can't be 2. This 4 eliminates 4 here, so it's 9. The pink needs access to a 4, so this cannot be pink. Which means that's red, which means this must be pink. And then the green has to go down here. So then we've got all the regions. This is a 4. This cannot be 4 here, or 9. 3, 8 pair. This 4 and 8 eliminates 4 and 8 here, so it's 9. This can't be 4 or 9. This can't be 4 or 9. Remaining digits in red. This digit is a 5. We have 2 and 9 remaining. This 2 eliminates 2 here, so this is 9. That's 2. This can't be 9. We have a 4, 8, 4, 8 pair in yellow, so this can't be 4 or 8, so it's 9, which makes this 3, which makes this 4. That leaves this digit as a 3, because that's the only possible digit left for 3. This 3 eliminates 3 here, so it's 8 and 3. 8 eliminates 8 here, so it's 5, which makes this 8, which makes this 5. This can't be 4, 8, so it's 9. Which means this can't be 9. Okay. Remaining digits in column 2. We have 8 and 9. This can't be 9 because of a 9 in the row, so this must be 8, which makes this 9. Remaining digits in column 3. We have 3 and 4. This can't be 3 because of 3 in the row, so this is 4, which makes this 3. Okay, this can't be 8. This can't be 5 anymore. We have a 1-4 pair here, so that's fine. Row 1, we have 2, 4, and 8. This can't be 4 or 8 in column 1, so this must be 2, which means this can't be 2. Remaining digits in row 2 are 1, 4, 8. This can't be 4 or 8 because of the 4, 8 in the column, so this is 1, which means this can't be 1, so this is 4, 8. This can't be 1. This 4, 8, 4, 8 pair eliminates 4 and 8 in the rest of the column, so this can't be 4. That's 1, which makes this 4, which makes this 8, which makes that 1. That means we have 2 and something else remaining, and 2 has to be here. This 4 eliminates 4 here, so it's 8, which makes this 4, which makes this 8, which makes that 4. Remaining digit here is 9. This 8 eliminates 8 here, so it's 4 and 8. And that's a solution. Pretty cool, actually. I've enjoyed these Chaconopia puzzles. It's been very interesting about the possibilities of what you can make. Plus, I like chaos construction rule sets a lot, so this seems right down my alley. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.